Okay, now on to the guided practice. So this one's a little bit long, but that's okay. We can handle it. That's why the lesson was so short. So a woodworker constructs a rectangular picture frame so that JK is 50 centimeters. So JK is 50. I can write on here. JK is 50 centimeters. JL, so the diagonal here is 86 centimeters. Find the measures. So first, they asked me to find HM. Okay, well, I know the diagonals have to be the same. So KM is 86. To get half of 86, we just divide by 2, and that gets us 43 centimeters. Okay, so there's our first one. Number 2. Now, they ask us to find KL. They want to be a little tricky here. KL. Well, I know JK. I know JL. How could I find KL? I'm going to have to use the Pythagorean theorem. So JL is my hypotenuse. I'm going to call this one X. So we're going to have to say X squared plus 50 squared equals 86 squared. Well, 50 squared is 2,500. 86 squared is 7396. Subtract 2,500. Bring it X squared equals 4896. Now, when I square root this, I'm going to get some big decimal. Some long, I'll say big, it's not big, but I'm going to get a decimal. Notice our instructions say to round to the nearest centimeter though. So yes, I'll take the square root, I get 69.9714. But to the nearest centimeter, that's 70 centimeters. Okay, so there's 1 and 2, dealing with rectangles. Now 3, we're dealing with the rhombus. 3 tells us that the measure of angle BCD. So BCD, that's this whole angle right here. This whole thing is 108 degrees. And then I have to find angles 1, 2, 3, 4, and 5. Sounds like a lot, but it's not too bad. I know that the diagonals, since I have a rhombus, diagonals bisect. So that means this angle is the same as that angle. These two are the same. These and these are the same. And then what do we know about how they intersect? Right angles. So angle 2 right here needs to be 90 degrees, period. Angle 2 is 90 degrees. That's non-negotiable. I'm gonna write a 90 right there, 90 right there, 90 right there. Okay, now angle 3. To get half of the 108, I just do 108 divided by 2. That gets me 54. So angle 3 is 54 degrees. But then that means angle 1 has to also be 54 degrees. Now, for 4 and 5, we're kind of stuck at a conundrum right quick. But let's focus on one certain area. Let's focus on this triangle. Because it looks like we're stuck. But if I ignore everything else, except what I know about this triangle, how can I get angle 4? What does a triangle have to add to? 180. I know 2 angles, so I just add them up. 90 plus 54 gets you 144. Subtract it from 180. So 36. So 4 has to be 36 degrees, which means 5 has to be 36 degrees. So the picture's kind of cluttered. If you're a little confused at how we got these, I suggest pausing it, going back, rewatching it, stuff like that. Okay, next one. Again, we're dealing with a rhombus. And they ask us to find the different measures. So first, we're asked to find AB. Well, AB is right here. What do I know about AB? Or what do I know about a rhombus? Period. All the sides are the same. So to get AB, let me find X, and I can just plug X in. So 4X plus 15 equals 7X plus 2. Subtract 4X. Yeah, 15 equals 3X plus 2. Subtract 2. We're going to get 13 equals 3X. Divide by 3. And we get that X equals 13 over 3. So now we can go back and plug it in to one of them. It doesn't matter which one, just plug into one. I'm going to do the 7X plus 2. So 7 times 13 over 3 plus 2. That's going to give us 97 over 3, which is approximately 32.3. I'll take either of those answers. Okay, number 5. They ask you to find the measure of angle ACB. So that's this angle right here, which they conveniently tell us is 4y minus 1. Okay, great, but what's y? Well, notice this angle, which has to be 90 because it's on the diagonal, is equal to 12y. So just solve that for y. Divide by 12. We're going to get y equals 7.5. So then just come back up here and plug in 4 times 7.5 minus 1. And that would get us 29 degrees. Okay, next one. We have a rhombus. So let's label what we know about a rhombus. We know diagonals have to intersect at a right angle, which means angle 4 has to be 90 degrees. We also know that not only are opposite angles congruent, but the diagonals bisect the opposite angles. So down here I have a 26. That means 3 has to be 26 degrees. Let's see, I know that's 90. I got a 26 degree angle down here. What's 1 have to be? Well, 90 plus 26 gets you 116. Subtract 116 from 180, and you get 64 degrees. So that means 1 has to be 64 degrees, which means 2 has to be 64 degrees, which means 5 has to be 64 degrees. Because remember, these angles are congruent. Okay, well, there's that one. And last but not least, we have number 7. It's a rectangle. Now, for rectangles, we do not know how the diagonals intersect. We can't say, oh, it's right angles, 4 and 5 are 90. No. We don't know that. What we do know, though, is that these have to be 36 degrees, though. So that means angle 2 is 36 degrees. We also know that each main angle is a right angle. So to get angles 1 and 3, we can do 90 minus 36. And that'll get us 54. So angle 1 is 54 degrees. Angle 3, 54 degrees. So now that leaves us with angle 4 here. Well, to get angle 4, let's focus on just this triangle right here. 36 plus 36 and subtract it from 180. 36 and 36. And 72. Subtract that from 180. Get 108 degrees. So that's what angle 4 is, 108 degrees. So 108 degrees. But now remember, this is on a line, so if 4 is 108, it still has to add up to 180, which means 5 has to be 72. To add up to 180, since they're on a line, they both together give you 180. That one's got to be 72. If you didn't realize that, though, you could say, okay, well, that's 54. That's 54. So 54 plus 54 gets you 108. Subtract that from 180. And you get, what do you know? 72 degrees. Okay, so there's the guided practice. Get to work. If you have questions, you know how to reach me.